So we are on the back of the page for the summary of energy, and I want you to circle kinetic energy. We have a paragraph about kinetic energy, and get your green colored pencil ready. So kinetic energy, this is energy that is carried by an object or mass in motion. So if an object is moving, it has kinetic energy. And this is energy in use, energy that is in use. This isn't stored, it's energy in use. So get your blue colored pencil because there's a pretty important idea here. Kinetic energy can also be transferred from object to object where contact is made, and sometimes even through wave energy. And this idea of wave energy we'll take a look at when we study solar radiation and the fact that solar radiation moves through space as wave energy. We'll take a look at that. But this idea of kinetic energy can be transferred from object to object where contact is made. A car slams into another car, that's contact being made. You have energy being transferred from one car to another. But also, thermal heat. Heat, we call heat thermal energy. So thermal or heat energy will move through matter to other matter. So think about this. This would be, you take a frying pan, you put it on the burner, you take a hamburger, you pop it in the frying pan, 5, 6, 7 minutes later, 10 minutes later, you've got a cooked hamburger and it never touched the fire. Because the heat, the thermal heat from the fire, moved through the frying pan and into the hamburger. So, thermal energy is heat energy moving through matter. Sometimes it moves through air. So here's kind of the most important part of this paragraph. If it can be determined that something is moving or changing, then it has kinetic energy. And let's take a look at these forms of kinetic energy that I've noted down below the paragraph. And let me just clear that ink. So I'm going to ask you to do the same thing with these forms of kinetic energy that I asked you to do with the forms of potential energy, but let's just take a quick look at them. So we have mechanical energy, and mechanical energy is pretty basically anything, it's matter in motion. Okay, so if you have matter, if you have air, if you have a car moving, if you have an object or matter in motion, it is considered to be mechanical energy. Mechanical energy is when energy makes matter move. So thermal or heat energy, we already talked about what this is, so we'll just really quick get it underlined with your green colored pencil. Atoms and molecules in motion. And this is heat moving. Atoms, one atom touching another atom, touching another atom, touching another atom, and the heat moves through those atoms or those molecules. And that would be thermal energy. So electrical energy is where you have electrons, little electrons. Mr. Woods, you mean like electrons that are in atoms? Well, actually, electrons moving from one atom to another atom to another atom to another atom and moving through matter like through a copper wire. Or if you've ever touched something that had electricity put to it, like an electric wire fence, going around a field, you've felt electrical kinetic energy. You felt electrical kinetic energy. Radiant energy. This is energy that moves through waves. And again, when we come to solar radiation in a few days, we will talk about how solar radiation is really waves of photons. Photons are actually solar, I guess we could call them solar particles. Interesting to think about solar radiation as being particles, but we call the solar radiation that moves through space in waves, we call it photons. We call them photons. And then finally, electromagnetic energy. And electromagnetic energy, these are this is matter also that that moves in waves, but it's magnetically it's electromagnetically charged. So one place where we see magnetic waves would be like in the Northern Lights, or the aurora borealis. And I have some videos that I can show you, or I can put up for you to link to and take a look at the aurora borealis, or the Northern Lights. So again, I want you to try to sketch a picture of each one of these and write a description of your pictures. So you'll have 5 pictures here, one of each of these types of kinetic energy, and then trying to describe them. And then finally we have one last paragraph, and we'll just kind of get this one last paragraph in right now. Let me clear the screen here again. One last paragraph, and it's about what we have learned in relation to work. So if you get your red marker handy, and let's read this paragraph. So work. Remember this: energy causes work to be done. If there's work being done, then energy is present. If there's energy being applied to something and there's change, or there's change, or something's moving, then work is being done. So work is done when something moves or is displaced. And displaced simply means something's moved from its place. We will also say for now that work is done when matter changes as a result of energy being released or applied. So like if you have matter changing states, or water gets warm, or water gets colder, we would say that work is being done. So we might also say that work is a result of energy being done on an object or matter. And let's just get your blue colored pencil and get the main ideas here. So if it can be said, or if it can be determined that something has moved or changed, then work has been done. And interestingly enough, this should sound like we're talking about kinetic energy, and we actually are, because kinetic energy is when work is being done. When work is being done, we see kinetic energy. So if you think about it, all these types of kinetic energy that you're going to sketch, you're going to draw some sketches of, each of these types of kinetic energy are actually we would say that work is being done if you observe each of these types of kinetic energy. So that might help you with your sketches. If you think about, okay, well, what it would look like for work being done, sketching mechanical energy, matter in motion. That's actually a pretty easy one. So if I erased these markings before you got them, please rewind the video, or drag the little bar back so you can get the markings back. Get your paper marked, and then please make sure that you get your sketches done and your descriptions written for each of the forms of energy that we've noted here.